Pete wants to buy a house for $225,000. The bank will loan, yeah, at 6% for 25 years. We need to know what the monthly payment will be. All right, so what formula do we need? If we look at our finance notes, okay, so this is a payment we're making, not a deposit, right? So that means it isn't a savings annuity. Savings annuity means we're depositing money. We're not depositing money. We're paying money. So that means it's either the payout annuity total value or the payout annuity payment. These second two formulas are both payout annuities. The alternative name for the second one is called an amortization payment. An amortization payment is a loan payment. So that's the formula we want. So we want the D equals blah, 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 blah. Or if we're using a spreadsheet, we can use the PMT formula. So I'm going to do it both ways, see what we got. All right, so it just, well, it don't feel dumb. It just, these are complicated. It takes a lot of getting used to. Tools, there they are. So let's see if I can get this right. The payment D is going to be equal to our balance, 225,000 times the periodic rate, which would be 6% over 12. What? In the spreadsheet, when it says number of periods, does that mean the years? Number of periods is how many total payments are you going to make? That would be how many payments do you make per year? 12 times how many years? 25. So it'd be 12 times 25. Yeah, we'll get to that in just a sec. All right, so I have set up my numerator here. Now I have to set up my denominator. So because of the room I have on the board, I'm going to put the big fraction bar. And so underneath here, I'm going to have 1 minus 1 plus my periodic rate, 0.06 over 12, raised to the power negative 25 times 12. So then I have to try to type that into something and see what I get. I also want to try the PMT. And the PMT formula, if you're using a spreadsheet, is going to want the periodic interest rate, the total number of payments, 25 times 12, and it wants the initial balance as a negative number. So that would be a negative 225,000. And the other fields are optional for this payment. Which negative part? This one or this one? So this one is just the way the formula is. The exponent has to be negative. Okay, so there's not much I can explain about that. It's just the way the formula is. This negative down here is because you owe that money. It's a debt to you, and that's why it comes out negative. And then the payment comes out positive because you are positively paying down that debt. You're taking it away. Yeah, so that's, otherwise the numbers get all negative backwards in the spreadsheet. All right, so I'm going to whip out my spreadsheet, see if I can reproduce the two of those. So let's see, somewhere we have let's see, testing finance functions. Let's play around here. Add a new tab called day 3. And then I'm just going to enter my information. I have a balance of $225,000. I have an APR of 6%. What else do I need to know? Years is 25.
No, not my calculator gave me something else.
You have something else? Okay.
On my tablet, it gave me like $220,000.
Okay, well, let's double check. So let's see, I want to calculate my payments. And let's blow this up just a little more. So I'm going to try the first version of the formula with the exponents and fractions. You got it to work? Nice. Wait, that's a different number than we have here. Okay, let's type it in and see what we get. So $225,000 times parentheses, the periodic rate, which is 6% over 12. And then I have to divide that, parentheses for the whole denominator, right? And then, let's see what I have. I have a 1 minus, parentheses, 1 plus, periodic rate. I should be pointing and clicking, shouldn't I? Oh well, too late now. Divided by 12, raised to the power, parentheses for the power because it's complicated. That would be years times 12, but negative. I always forget that one. Close the parentheses for the exponent. Close the parentheses for the denominator. Oh, I get $1,449.67. Okay, so let me try the other version because you said you got the PMT, $1,449.68. That's what you got? Okay. So Ian is somehow out of line. We'll figure out how. All right. Let's try the in the Google calculator, Excel. So you got this? Excel should, I just did this in Excel or Google Sheets, which is the same thing. I'm going to try the PMT formula. PMT says, what is your periodic rate? That is 6% over 12. What is your, next, number of periods? That would be 25 times 12. And what is the present value of the loan? That would be a negative 225,000. Close parentheses, and I get $1,449.68. Okay, let's troubleshoot. Make sure everyone's Fran, how did you do? Did you get the right answer? Or did you get this answer? You're still working on it? Okay. Let's check with Ian back here. You didn't delete what you had, right? Okay. Close the numerator, close the denominator. Oh, and you're missing a 1 minus right there. Yep. What the hell? Okay. Double click that guy up there. Okay. So you've got 225,000. Oh, no, you have a different amount. You have 250,000.
Oh,
yeah, so that's why it's consistently wrong. Change that to a 225 and they'll all come out the same. Ah, there we go. Okay. Ian's got it. Okay, how's it going over here?
It's good. That was my initial answer.
Okay, but you're having a hard time getting this to come up with it?
Actually, I'm having a hard time.
Okay. Is that with the negative, what's the negative 300?
Oh, I don't know what I
Just, you got to slide this way. Yeah. All right. Oh, you just did something.
Yeah.
Okay. All right. So are you going to try to type it in like I did there?
Yeah, what did you use?
I used both versions of the formula. So, yeah, so first time I did it, I typed the top equation. Second time I typed the PMT function.
Well, I did the PMT version.
You got it right.
It gave me 0. Yeah, I don't know. Like how?
Okay. All right, so equals PMT. Okay, double click it. It's 6% isn't your rate. It wants the periodic rate, which is 6% over 12.
Okay.
And then the E3 is not negative.
Okay.
That should be positive, not a negative. So you need to fix E cell E3. Get that negative out of there. Enter. Go back to your payment over here.
There it is.
Well, it's negative though. We want it to be positive. So double click. Your balance D2 is a negative number according to the payment formula. So sneak a negative in front of there. Okay, enter. All right. All right, Julia, how are you doing? Still working on it? Okay, yeah, keep typing. All right. All right, so everyone seems to be on the right track. Fen, did anything ever come up?
Yeah, I got it.
Excellent. Okay. So just a reminder about using some of these spreadsheet formulas. Okay, so spreadsheet finance functions, they will often ask for a rate. Super important, the rate is the periodic rate. For us, that usually means take the APR and divide by the compoundings per year. We usually call that K. We usually call it R over K. So if you just plug in like 6% for the rate, it's not going to give you the right answer. It needs to know the periodic rate. And then the number of periods, that's always going to be N, the number of years, times K, how many times a year do you make payments or deposits? Okay, so it's got to be the total number of times a transaction happens, whether it's monthly or quarterly or whatever. So those are the most common places to have a problem. And then usually whenever we're making a payment or we have a balance, it's often going to be a negative number because it's a debt for us or it's leaving our pocket. Okay, so in most of these formulas, we plug in a negative something or other. So those are the three things you want to consider when you use the spreadsheet formulas. So looking back at that list of functions, not all the time, but for most of these, let's see, compound interest formula wants a negative present value when you use that. Savings annuity is one of the rare examples. That one, we're putting a deposit in the bank, and that's a positive number. Savings annuity, calculating the payment, negative present value. Negative payment, leaving our pocket. Negative initial value, it's a debt for us. So most of the time, not all the time, but most of the time. So we always have to be careful about that. And usually what helps me figure it out is if I do the calculation and the number seems right, but it's negative, I should have made one of the numbers inside negative, the dollar amount inside. So, all right. Okay, so let's go back to this problem with Pete. Julie, did it work out? Excellent. Yeah, so and the more you practice it, the better it gets. It's just parentheses, 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 getting them in the right spot. It takes a little practice. So Pete bought this house. Anybody know what current interest rates are for houses if you have good credit? Yeah. Yeah, they're much lower than 6, right? So Pete's thinking, man, I didn't get a good interest rate now. I'm hoping to improve my credit and in 5 years get a better interest rate. So he wants to refinance this house in 5 years. Okay. Question is, how much is going to be left for him to pay off? And there's a couple ways we can figure that out. So Pete wants to refinance, hoping for better rates. Okay. So we need to know, what will the balance be then? What will the loan balance So here's the way to think about that. He's paying $1,449 and some cents every month. He's supposed to do that for 25 years, right? He's done it regularly for 5 years. Okay. So if he didn't refinance, he would continue to do this for another 20 years, right? So it turns out all we have to do is figure out, what are those 20 payments worth now? Sorry, 20 times 12, 120 payments worth now. That's all we have to figure out. So basically, we get to go back and use the formula prior to the one here. Okay. So what we have is a payout annuity or a loan formula. We know D, what he's paying. We know how long he's going to be paying it for. That should give us the current value of those payments, or at least at that point in time. Okay. So we should be able to just plug his current payment into this formula, and that will tell us how much more he owes on the house. And I'll confirm this with a spreadsheet in a minute. So what I'd like you to do is check out the payout annuity formula with that $1,449 payment for 20 years and see what you end up with. And we'll compare that to my spreadsheet analysis of this. Yeah, for 20 years, right? Because he's paid for 5 years. He's going to pause, hope to refinance. How much will he have to pay the bank off to get a new rate? Is what this is answering for us. So give that calculation a shot. Make that disappear for 1 moment, and it will come back. Oh, there it is. Good. Uh-oh, where'd my file go? There it is. Oh. It's going to be negative 20 times 12, because there's 20 years remaining worth of payments. I get in 5 years he will still owe over 200,000.
Oh, okay.
202. I get 24347. So it depends on if you did any rounding on the payment. Okay. So let's see. All right. So here, I ran that formula through on the spreadsheet here, taking my payment as D, right? I have my 6% divided by 12 months in a year to the power negative 20 times 12.
What did you get?
I got $202,347.20. You should get something close to that. I should be positive. So if you used what, the PV formula?
I got it.
You see where you're? Okay. So I'm going to use the PV formula.
I got the same.
PV says periodic rates, comma, what does it want next? Number of periods. That I don't have. I'll have to type it manually. 20 times 12 or 12 times 20, comma, payment amount. That is going to be a negative version of this payment up here, and that's all I need. And if I round, let's see, that to the nearest cent, actually 1449.68 will probably come out slightly different. $202,347.45. So rounding will make a difference over time. In the top version, I entered this number right here in this cell, and actually the computer knows a lot more decimals than it's showing me. And so when it computes this, it's actually using all that extra information, even though it's not showing it. When I did this one right here, I used the rounded version, exactly 68 cents, not 68 and fractions of a cent. Okay, so in 5 years, Pete will still have $202,000 roughly to pay off. Okay. Now I'm just going to confirm that that's true by setting up another sheet here. So in this sheet, I need to keep track of the month. I need to keep track of his payment. I need to keep track of how much interest he owes. What else? He's going to have a balance reduction. I did this with you guys the other day in class, didn't I? We're doing an amortization table. Look familiar?
Yeah, you did.
Okay. So this is super powerful. There's a video at the top of our finance that goes over how I built this, and I'm just going to review it with you again. So here's how I set this up. I'm going to say in month 0, we're starting with a balance of $225,000. I'm going to confirm that we're not lying about this, because how do we know we didn't use the wrong formula? Right? We made our best guess, and we think we're right. But this will confirm it. And then in month 1, I'm going to make a payment. Now, I think the proper payment came from that PMT formula, which is the same thing as our crazy formula. So I'm just going to say, grab the payment from up here. We believe the bank told us that's the right amount to pay. Okay? The bank will tell you this. How do we calculate interest? Well, you send this to the bank. The bank says, for the last month, you have owed us interest on this much money, right? What's our interest rate? Well, interest amount comes from taking your balance times your rate, and then multiplying by how much time has elapsed. How much time has gone by? 1 month, which in years is 1/12 of a year. So then I multiply by 1/12. So they say, okay, you owe us $1,125 in interest. So as soon as they get this $1,500-ish, they immediately say, give us the interest now. So that means they're going to do a subtraction. They're going to take our payment, and they're going to remove what they believe we owe them in interest. That leaves only $300 roughly for me to reduce my balance. So in the beginning of a loan, you pay a lot in interest and you don't get to reduce your balance by much. Okay? So my balance at this point was that much. Now I need to get to reduce it by this much because I owed the bank interest. That's just simple interest. That's the way they calculate it. Interest is just the balance times the interest rate times how much time has elapsed. So I took my 6% times 1/12 of a year.
Is that what you use for the student class?
Same exact thing.
Yeah, so I can just go back and look at it.
Yep, it's identical. Once I get these formulas typed in here, so my formula for the payment just says look there for the payment amount. I put a $sign in front of the 3 to say it's always in row 3 there. Okay. My interest amount says take my previous balance, multiply by the interest rate, and then multiply by 1/12. Does the balance change each month? The number in E10. Yeah, it's going to change each month, so no $sign there. The interest rate, however, is always located in row 2, so I got to sneak a $sign in front of the 2 there. Okay. Balance reduction, it's always my current payment minus my current interest, no $signs. Those change every month. Okay, see you later, Micaiah. And then my new balance is always the previous balance plus the new reduction, so no $signs. Once I get those set up, I can just highlight all of them in one shot and then grab the right corner and fill down as far as I want. The question is, how far do I need to fill it down? Well, how long is my loan period? 25 years. 25 times 12. 300? Yeah, 300 months. okay? So let's get the months going here. So 0, 1, 2. So to get a 1, 2 going along with those payments, I have to highlight 2 rows at a time and then fill this down till I've done 300 payments. And at the end of 300 payments, I should have a perfect 0. And oh, I didn't quite get, oh, that was close. Oh, perfect 0 at the end. That's what an amortization payment is designed to do. Fixed monthly payment that pays off some big amount or small amount over a given time period. Given time period is important. All right, let's go back. We wanted to refinance after how long? 5 years. So we want to see what happened in 5 years. What's the balance after 5 years? Let's see, 5 times 12 is 60. So after the 60th month, or in the 60th month, how much do I still owe? Let's see, I got, oh, a slightly different answer. Oh, 60, wrong one. There's the 60th month. 202, I can't read. 2,000, $202,437, $347.20. Does that now amount look familiar? That's the one we just calculated. Yeah. So that crazy formula does confirm that that's the balance that he has to pay off if he wants to continue at a different interest rate. So then he negotiates with the bank. I'm all excited now. I can't talk. To get a better rate, and maybe the bank says, "Okay, we'll give you 4% on that 200,000." Is it worth it to refinance? Let's double check. So let's compare at this stage in the game. Let's see. I'm going to type 4% right here, and I'm going to type the 6% that he's currently paying right here. So I want to know what's 4% of 200,000. So equals 200,000 times 4%. Let's do it for 1 month, 1/12. And then I do the same thing here. Take the balance times the rate times the time. Over $300 difference in 1 month. Is it worth refinancing? Maybe. Okay. So then the bank says, well, to refinance, we're going to charge you a fee of $2,000. Right? For all of our trouble in redoing the paperwork. Okay. Is it going to still be worth it? Let's check. So we're going to reproduce this table for the 202,000 and see what happens over the life of the loan. Actually, we don't even need to reproduce the whole table. We can do it without that. So let's go to, let's see, I need a new sheet here. So we did the calculation here. Let's see if I can type the number right. His balance should be $202,347.20. And we're thinking about refinancing this amount over 20 years at 4%. So we need to recalculate what his monthly payment's going to be. That was that first formula we used. Okay. So new page, we need to find, everyone whip out your calculators, the monthly payments for that 202,347.20 at 4% for 20 years. Right. He doesn't want to extend the time anymore. He just, let's get it done in 20 more years. That's what I originally had to do. So what's his payment? Payment here is going to be called D. Whip out your favorite formula for it. Take a look at that cheat sheet. Calculate something. Let's see, which one is this again? I want PMT. All right, so I have the spreadsheet function versus the formula from our cheat sheet. Whip out your favorite calculator. Sneak mine over here. I'm getting it's like $200 cheaper than his last payment. Anyone else get that? Still working? That's what you got? Okay. So let's say everyone else catch up. Yep. Oh, yep. I get the same number each way. So I'll give you all a minute to catch up with all those parentheses. Amortization payment? Yeah, we're calculating the amortization payment. You got a different number again? Okay. So double click. Because we're going 4% here, not 6%. Yeah. Yeah, at 6%, at 6% he'd be just be picking up where he left off, so you would get the same monthly payment. Yeah, but we're going at 4% now. I don't know. That's a tough one. Any luck? Still working on it? Did they come out yet? Or are you still typing? That's a lot of typing, I know. No. Got it? Okay. So here's the next thing I want to take a look at. Is it worth it to refinance? Well, he is paying like $220 something less a month, right? Okay. How many months? Well, 12 times 20. So it's, no, 240. So 200, he's going to be saving roughly $200 a month for 240 months. That should add up, shouldn't it? Yeah, just like double check before I do the total payments. Let me finish total payments. He's going to pay that much every 12 months for 20 years. So he's going to pay out almost $300,000. He's saving roughly, what, $223 a month times 12 months times 20 years. So he's saving 50-something thousand right there, it looks like. And they want him to pay what? An extra $2,000 up front to make this transaction? Pay $2,000 to save $50,000? Okay. Now, it's over an extended period of time. That is still important. Do you have an extra $2,000 right now? Yes or no? No? Sorry. Can you come up with it? Maybe. Some other things to check. So the total payment was that much. So the amount of interest that he's going to pay altogether, well, he made that many payments, right? But he only owed $202,347. So that means he's going to pay $91,000 in interest, almost $100,000 in interest alone. If he kept the other loan, he'd be paying more than an extra $50,000 over that 20 years. Let's see, how many people could use an extra $200 a month in their pocket? Yeah. So in 10 months, he pays off that fee. Okay. So provided he can come up with that $2,000 to refinance, is it worth it for him to do so? Answer is yes. So guess what else banks will do sometimes? They'll say, well, we know you don't have that $2,000 now. We'll just throw it into what you owe us. So now you owe us $204,000. Okay. Is that going to be a big deal? Okay, so let's suppose we switch this to 204. So I'm just going to add $2,000 to that. His payment goes up by, how much did it go up by? Anybody notice there? What was it supposed to be? 200 and, what do you have on your screen? Yeah, what did you just calculate for the payment? 226. Okay, so his payment just went up $12 a month to deal with that $2,000 refinance charge. But he's still saving $200 a month compared to what he would be paying at the 6% rate. Okay. So this is complicated, yes. However, just some things to consider in our work here. The amortization sheet, once you've done it a couple of times, isn't that hard. All you have to do really is know how to calculate the simple interest part. That's the easiest formula we've done yet. So that's not too bad. And we have all those other crazy formulas, but we also have spreadsheet versions of those that prompt us what to type. Do they always give us the best prompts? No. They say, give us the rate. Well, which rate do you want, right? The periodic rate, the yearly rate? Generally, they want the periodic rate. And once we play with them a few times, we get used to them. If you don't do this in a year, will you forget? Absolutely. But you might remember, hey, Parker had a sheet that had all these on them, right? You could just email me and say, hey, where's that sheet again? I'm thinking about buying a house. I want to do the analysis. And even if you don't think to ask me, if you just go online and you search for amortization calculator or loan calculator, lots of companies have developed these loan calculators where you just go there and you plug in information and out pops answers for you. Do they do that whole amortization sheet? Some of them actually will spit out that whole sheet. Banks, when you do the loan or you're planning on doing one, they'll give you a summary of an amortization sheet. They usually don't do the whole thing for you, but you can always ask for it. So here they have a home loan calculator, auto loan calculator, personal loan calculator, and the bottom line is they all make the same calculation. It's the same formulas we're using. It's just, you know, mortgage rates are usually different than auto rates, then slightly different than personal rates. But that's the only difference, the interest rate. And then they'll ask you questions like, what's the mortgage amount? Well, $225,000. How many years? 25 years. Let's see, and then, or I could enter number of months. So let's see, what was 300? And our rate originally was 6%. And we can hit calculate. And oh, they want the mortgage start date. Today, what is today? 10/21/016. Okay, calculate. And they should come up with that same number we just did. Come on, is it doing it? It's thinking. Oh yeah. I've never used this particular calculator before, so I don't know if it's going to work. Where is it? It didn't do anything. What happened? Okay, 225 is still there. Oh, it says 30 years. I wanted 25. They're trying to sell me. We're up here. Yeah, they're trying to sell me something there. Don't be careful where you click on these pages. Mortgage start date. I don't know. Let's enter a future date. How about 1/1/2017? Oops. Maybe I picked the wrong calculator. Calculate. Must be 10 characters. 01, 01. Okay, last time I give this one a try. Come on, you can do it. You can do it. Give me the monthly payment. Ah, it flaked out on me again. Oh, well. Okay, they're out there, and there are other ones that I'm sure work. I'm not going to waste any more time on it. Oh, it's still thinking about something. Okay, anyway, we're done with that. Let's see, what else did I want to do? Fen, did you have that question about where that first formula came from still?
Yeah.
Okay, let's go over it then. So I'm going to do, so on page, I think it was 205 in the book, they go over where our savings annuity formula comes from. I'm going to do a short version of that right now. So here's my short version for where the savings annuity formula comes from. It's going to take me a couple of screens. So starting information, we're going to make a deposit of $100. It's a nice easy amount. For a rate, let's do 12%. And then for our compounding period, let's do quarterly. And let's just do it for 1 year. Otherwise, it gets very messy. And so I want to see if I can develop our formula for this. And I got a crazy mathematical trick to throw in to do it. All right, so here's the way to think about it. I'm going to make my first payment. So let's look at payment versus time of $100. 1 month is going to go by on that payment. Let's see. The payment happens at the end of the month. So after 1 month, I'm going to have $100. Let's see, what's my growth multiplier going to be here? Yeah, so the growth rate is going to be 12/4. So thinking back to last term, growth rate, GR, is 12% over 4, which is 3%. How do I turn a growth rate into a growth multiplier?
+1.
+1. Just add 1 to it, right? And write it as a decimal, right? So the growth multiplier, let's call that the GM, that's going to be 1 plus that, so it's going to be 1.03. Okay, so every period that goes by, in this case, I think I said month earlier, I meant quarter, we're doing quarterly. So after 1 quarter, I should have 1,000 times 1.03. Okay, and then I make my next payment, and a month goes by for both of these. The top one gets another 1.03 multiplier onto it, right? Because it's collecting interest. So it's now going to be 100 times 1.03 to the second power. And this guy gets a 1.03. Just one so far. Okay. Time goes by, I'm running out of room. I need a bigger board. Let's see. Give myself a little more room. Tab view off. That's kind of better. Oops, that's not what I meant to do. Now we're just going to do it oops, I missed. I'm just going to go for 1 year, but yeah, if we were doing 20 years, we just keep going and going and going, and just keep growing down and out. But I'll summarize. It summarizes quite nicely. That's why I'm only doing 1 year. Let's see, is that far enough? Okay. So this is, let's see, first quarter, second quarter. So now we're jumping into the third quarter here. We make a payment, and time goes by for everything. And so we all get bumped up. This will now be 100 times 1.03 to the third power. And this will be 100 times 1.03 to the second power. And this one has just had 1 month to collect interest, so it's now 1.03. And you could say it's to the first power. Now, the catch to make here is the payments are being made at the end of the month. Okay. So I'm now at the end of quarter 4, and I make my 4th payment. And it's the end of the quarter, so there's no more interest collection. So these are the final amounts of money in my account. Right there. And there's a pattern to these. The 1.03 is to the third power, second power, first power. This is actually the 0th power of it. Yeah, which is 1 times 100, which is just 100. Okay, so I'm just going to write that out in a different way. So the 20th payment, sorry, let's say 20 quarters instead. The 20th one would have the power 19 because it was made at the end of the month, right? So at the end of quarter 1, I make a payment. Over time, I look at the end of quarter 2 and I finally get the interest. Then we get to the end of quarter 3 and I get some more interest. And then at the end of quarter 4, I finally get interest again on that payment. Okay. So we get this delay because it's at the end of the quarter. And all the spreadsheet formulas in the spreadsheet, the functions, that is the PMT and the PV and so on, they have an option for was the payment or deposit made at the beginning of the month or the end of the month. That's the 0 or the 1 at the end, yeah. So if 0 or you don't put any extra thing, that's assumed the payments were made at the end of the month. If payments were made at the beginning of the month, you flag it with a 1. Yeah, and that's in the details of all these functions. So if you go to the second and third page of the function notes here, you'll see that they all have a last position that is a 0 or a 1 for the beginning or the end of the month for payments. They all have that option. What if you make your payment in the middle of the month? Well, this doesn't help. Then it's a little more complicated. Well, usually what the banks do is if you make it somewhere in the first 2 weeks of the month, they call it the beginning of the month. And if you make it in the last 2 weeks of the month, they call it the end of the month. But they have leeway as to how they define that. Okay. All right, so let's go back and clean this up a little bit. So what we've done is we've generated this interesting sum that goes, oops, I need a pen. It's a highlighter, I'm sure. Oops, I undid something. That's not good. I don't know, but it's not happy with me. Don't close the program, please. I closed the program. I'm having all kinds of interesting technical issues today. Oh, yes, please attempt to recover lost data. All right, how did we do? We didn't get the stuff we just did. Okay, so that's okay. I'm just going to summarize what we did. That's what I wanted anyway. And I need my tools back, please. Oh, there's 2 files here. What's in the other one? Nothing. Okay, and the tools are missing. There they are. Okay, so here's what we're at right now. And I'm going to state them in reverse order. So our last payment didn't get to collect interest. That's just 100. Our second to last payment got to collect interest for 1 period, 1 quarter. Our second payment got to collect interest for 2 quarters. And our first payment got to collect interest. Uh-oh, I'm running out of room. For 3 quarters. Ah, missed. Still missed. There we go. Okay, so that's the list we have. And again, we have 1, 2, 3, 4 things to deal with, and they are all are what are called exponential items because the exponent is going up by 1 each time. So this is exponential growth or geometric growth. It's not linear growth. All right, so here's the trick for dealing with these things. What you do is you basically make and then imagine that there's 20 or 100 or 300 of these, right? If we were doing every month for 25 years. So this could be a super long list. So to shorten the list, we do the following trick. We take our sum, and I gotta shrink this. There we go. Yes, got them all. Yeah, so we say, okay, this is my sum. The 100 is the same, every part of the sum. What differs is the power of the 1.03. So the trick is to take 1.03 and multiply it by both sides of this equation. It's a weird trick, but watch what happens when I do it. So then that means I'll have this first 100 will be 100 times 1.03 to the first. This second one will become 100 times 1.03 to the second. This guy will be 100 times 1.03 to the third. And then this one becomes 100 times 1.03 to the fourth. Well, since I multiplied by the 103, all the exponents got bumped up 1, right? Okay, so what? Why? Well, here's the deal though. Now these two lists have some things in common. What do these two lists have in common? Well, both of these lists have a 100 times 1.03 to the first, and a 100 times 1.03 to the second, and a 100 times 1.03 to the third. Imagine if there were 300 of these items. They would have all these middle things in common. What wouldn't be in common was the first one in that list and the last one in that list. Now, what happens if I subtract these two lists from each other? Yeah, I just get the beginning of one and the end of the other. They collapse. So imagine instead of having 4 terms, we had 360 terms. 358 of them disappear if I subtract these two statements. Okay, so the trick here is, let's see, I'm going to take the blue one away from the black one. Okay, so again, if I write that down based on the left side here, if I do a subtraction, I'm going to take the blue thing away from the black. So that means I'm going to have a 1.03 s minus 1s. The blue thing is my 1s. On the other side, I'm going to have the 100 times 1.03 to the fourth power. Subtracting all of this stuff leaves me a minus 100 at the end, because all these middle ones subtracted out. So no matter how many terms there were, whether there's 4 or 360, all but 2 disappear. Now here's the cool thing. I want to know what the sum is. Come on. There we go. It's right there as a letter S. So let's see, if you have 1.03 S's and you take away 1 S, what's left behind? 0.03 S's, yeah. So on this side, I have 0.03 S's. And on the other side, I have, oh, I could factor out this 100, couldn't I? So I have 100 times 1.03 to the power 4 minus 1. Right? Because if you distribute that 100 back through, you get what's above. Factoring out is like division. If I factor the 100 out of here, I have a 1.03 to the fourth. Factor 100 from 100, 100 divided by 100 is 1. Right? So factoring is division. It leaves a 1 behind often. To finish solving for S, all I have to do is divide by the 0.03. So that means S has to be 100 times 1.03 to the power 4, then take away 1, and then divide that by 0.03. Okay, what is the 0.03 to us in this problem? Is it the APR or the periodic rate?
Periodic rate.
No, it is the periodic rate. The APR was 12%. We divided by 4 because that's how many periods we have. So that's the periodic rate. So check this formula out. Now look at the annuity formula. This, let's see, this is the savings annuity. Look at the savings annuity formula on your cheat sheet. So I'm going to make a copy of that and throw it over here. Oops, that's not it. Escape. Escape. Hello, escape. Where'd it go? Okay, here it is right there. So let's check to see how this worked. Screen clipping one more time. Clip this formula right here. Blow it up a little bit. Okay, do D, that's our monthly payment. Do we have a monthly payment? Yeah, it's our 100. Then it says parentheses, take 1 plus the periodic rate. Do we have 1 plus the periodic rate here?
Yes.
Yeah. Power, NK. So that was 1 year for 4 periods. 1 times 4 is 4. Minus 1. Divide everything by R over K, which is the periodic rate. We just proved that formula is true with that little weird trick I did. Yeah, and so that's what they go over on pages 205 and 206 in the book, but they use a lot more periods to do it, which maybe if you look at that now, it'll make more sense after we did this here. But I did this weird trick I did here, that is pretty bizarre. That if, and here's the cool thing, somebody had to notice to do this once upon a time. I mean, like, if you guys think I know a lot of math or I'm smart, I didn't create any of this stuff. I just help other people learn it. Somebody else had to come up with all this stuff. Right? So some amazing person once upon a time found this, maybe by accident. Most likely they were messing around trying to get things to work, and they're like, oh, look at that. That was a nice accident. It worked.
You can say you can have 5,000.
Yeah. So we had to do this crazy subtraction to make it work there. But it worked. Okay. So that's why that formula works. Each of the other formulas is basically a tweak of this situation right here. So to get the savings annuity payment, all we have to do is switch through multiplication and division, D and our sum there. And the other formulas basically are like traveling back in time, which is why we get negative exponents in the next two formulas. But I could use a similar trick to show how that works out. Bottom line is, I don't need you guys to create these formulas from scratch. I just need you to figure out what scenario you're in, which formula to use, and then be able to do the formula. But sometimes it's nice to know where things come from. This will not be on the test. You won't have to create the formula, you just need to use it.
So we can bring the sheet into the
Yeah.
test.
So for the test, you can use a spreadsheet if you need one. It has to be a blank spreadsheet. And you can use this finance sheet here. And then other things that you might need, if you take a look at the sample test, let's bring that up here. 105 fall, midterm, sample. So I give you those same formulas here. I also have list the logistic growth equation. So I'll give that at test time too. And then I also give a bunch of common conversions. This was one of the pages in our book. So you don't need to memorize any conversion facts. If the test happens and you need a conversion fact, just let me know. So Fen, if you're in Milton and you think you didn't get a piece of vital information that you need to solve a problem, just have the Milton Setter call me.
Okay.
Okay, or you have my email address. You could email me during the test. That would be okay.
But we can bring the finance note in there, right?
You can bring that finance sheet here, yeah.
Okay.
You can bring this sheet into that, yeah. And what I'll probably do is I'll just attach it to the test so that the people in Milton don't have any doubts about it.
Okay.
Yeah. And then you can take the test any day next week, Monday through Friday. Just let me know when you want to do it.
And we can bring the calculator too, right?
You can use a calculator or you can use a spreadsheet. And then you got to do the practice test before I'll let you do the real test. So either you have to hand me the paper version done, or I have to be able to look online and see you took the online practice test. So you need to do one of those before you can do the real thing.
All right. So if we want to use the spreadsheet, the Excel, or like how can we use it during the test?
Hang on, I had two people talking at once there. Fen, can you go? And then Ian, I'll get you again. Hang on. Go, Fen.
Okay. So during the test, if we need to use the Excel, which is spreadsheet,
Yeah.
so how do we do that? Will we allow to use the computer?
Yeah. Yeah. So when the test will be online. So what'll happen is you'll go to the Milton Center, for example, or if I can't meet with one of you, you'll go to the testing center here and I'll have to let them know. And you'll come in here and you'll click on the midterm exam and it'll pop up saying, hey, what's the password? And so whoever gives you the test will have to plug in the password.
Mm-hmm.
And then they'll also know that you can use a spreadsheet. So when you open the test, you should also open up a blank spreadsheet in case you need to use it.
Oh, okay, that's great.
And then if you do use a spreadsheet, the last question says either upload your Excel sheet or give me the shareable link to your Google Sheet if you use Google Sheets.
Mm-hmm.
Okay.
Mm-hmm.
All right, Ian had a question. The one we worked on today, you want me to share that one? Yeah, I'll share it with everybody. So what I'll do is I will, let's see, my open math back. I will, I'll post it in the problem solving forum. So where's that? Not problem solving, what are we in? Finance. Yeah. So AJ found a cool compound interest website. I'll post some useful spreadsheets. So those spreadsheets that have the amortization table in it, you wouldn't be able to use one of those on the test, but you can certainly look at it to learn how to build one. Yeah. And if you ever, have a credit card debt, if you ever buy a car or a house, that spreadsheet's a great thing to have because you just plug in your numbers and fill down however many rows you need, and you have a month-by-month analysis of what you're going to do, which is pretty nice. So that's a super awesome spreadsheet to have. Yeah, so I will share that with everybody today. All right, that's it for today. Have fun, finish your homework, and do math, get rest, eat well, all that good stuff. All right, I'll see you later, Fen.
Okay. You already shared the spreadsheet we did in the class, right?
I'm going to share in the finance forum here the spreadsheet today.
Oh. Okay.
So you'll be able to find a link to it here.
Okay, great.
Okay.
So yeah, I'll do my practice and I'll email you if I have questions.
Okay, have fun.
Thank you a lot. You have a great day.
Bye-bye.
Bye.